Hi, in this video we are going to talk about other types of heaps such as binomial heap or Fibonacci heap, because the eternal questions concerning data structures that can we do better. And as far as the insertion operation is concerned for heaps, the binomial heap and Fibonacci heap can do better. So binomial heaps are similar to a binary heap, but also supports quick merging of two or more heaps. It is important as an implementation of the mergeable heap abstract data type, the so-called multiple heap, which is a priority queue basically, plus it supports merge operation as well. A binomial heap is implemented as a collection of tree-like structures, and the insertion, which takes logarithmic time complexity for binary heaps, can be reduced to ordo 1 constant time complexity with the help of binomial heaps. So binomial heap, we have several tree-like structures. We can merge these kinds of tree-like structures. And why is it good? Because in the end, we are going to end up with an algorithm that's going to be able to insert new items in constant time complexity instead of the logarithmic time complexity. What about the Fibonacci heap? It is faster than the classic binary heap. Dijkstra's shortest path algorithm and the Prim's-Yarn expanding tree algorithm run faster if they rely on Fibonacci heap instead of binary heaps. So Fibonacci heap is quite important, but it is very hard to implement efficiently, so usually doesn't worth the effort to implement it from scratch. Unlike binary heaps, it can have several children. A number of children are usually kept low, and we can achieve ordo 1 constant time insertion operation complexity instead of the logarithmic one. Why is it Fibonacci? Because every node has degree at most ordo log n, and the size of a subtree rooted in a node of degree k is at least f sub k plus 2, where the f sub k is the kth Fibonacci number. So it has something to do with Fibonacci numbers. And why is it good? Because the binary heap, as we have discussed earlier, we can find the minimum or the maximum in constant time complexity, but if we would like to delete, if we would like to insert or decrease a key, then it's going to take logarithmic time complexity. On the other hand, binomial and Fibonacci heaps supports other operations such as merging, but which very interesting is that the insertion operation can be reduced to constant time complexity ordo 1 instead of the binary heap logarithmic complexity. So this is why it is good to use binomial or Fibonacci heaps. Thanks for watching.